This is exercise for lab number 2 of Dreamcatcher's ME1130, Essentials of LTE and LTEA University courseware, captured on video. During this lab exercise, we are going to set up and configure an LTE base station. After that, we are going to perform an LTE network performance measurement and analyze the performance results. To get the most out of this course, you should view this video along with the lab sheet. Please refer to the description section for the lab sheet download link. You may want to pause this video to read the lab sheet first before proceeding with the video stream. In this lab exercise, you will learn how to set up an LTE base station on a mini PC that runs Open Air Interface, eNodeB, and EPC Core, MME, SPGW, HSS. A commercial off-the-shelf UE, such as an LTE dongle, will be used to connect to the LTE base station. You will then be able to access the internet from the UE. These are the components and interfaces in the LTE network setup in this lab exercise. The eNodeB and MME, SPGW, HSS are running on a single local host computer. The eNodeB has two interfaces to MME and SPGW. S1 MME interface is the control interface for exchanging S1 application protocol signaling messages with MME. S1U is data plane interface for data packets. Note that MME and SPGW is a single executable in OAI. They communicate with each other via intertask interface queue. The HSS is a separate executable, communicates with MME via S6 interface. We are now going to set up, configure, and implement the eNodeB and EPC using OAI and establish a working LTE network using COTS-UE using the Dreamcatcher ME1130, Essentials of LTE and LTEA training kit. The training kit consists of a mini PC, a Lime SDR, a Lime SDR Mini, and an LTE. Turn on the mini PC and log in. Refer to lab sheet for the steps to configure the eNodeB and EPC in the mini PC. Then, start the LTE by executing the following command. Open a new terminal and run the HSS, start another new terminal, then run the MME. At the HSS terminal, this output message shows that the HSS is successfully started. If everything is fine, the terminal will start displaying the statistics of all connections. Start a new terminal and run the SPGW. Some new windows will appear such as the soft scope and 1 lira and 2 lira statistics. The soft scope enables you to monitor the PHY layer for both eNodeB and UE. This tool plots the received signal power, channel impulse response, channel frequency response, log likelihood ratios, throughput, and IQ components. For example, 16QAM constellation. On the other hand, the PHY or MAC statistics windows display online statistics for the status of the network, such as eNodeB measurements, noise, signal power, and so forth, UE feedback, CQI, and so forth, and uplink and downlink hybrid automatic repeat request statistics. For example, uplink shared channel or downlink shared channel errors per HARQ process. 8 in LTE FDD per round. 4 is the maximum. Turn on the Windows PC. Now let's set up the LTE dongle. You should see a web page with the address http 192.168.8.1 opened once you plug in the LTE dongle. The status, no service, indicates that the UE is not connected to the LTE network yet. Configure the LTE dongle. After configuring the LTE dongle, go to Home, and you should observe that the LTE dongle is now connected to the LTE network 90,170. Now, you should be able to browse the internet. If the UE has connected successfully to the eNodeB, you will see this appears on the MME terminal. The soft scope for UE0 will start to show the collected uplink data, such as the received signal, SRS frequency response, channel frequency response, physical uplink shared channel, log likelihood ratios, PUSCH throughput, PUSCH, IQ of MF output, physical uplink control channel 1 energy, and PUCCH, IQ of the MF output. Now let's perform some simple network tests using any one of the popular online internet speed test programs. Record the download and upload data rates in the table. Repeat the test 5 times. In the stat window, observe the modulation and coding scheme index for the download and upload. Record the observed maximum and minimum values in the table. Open a new tab in the web browser and enter the URL http 192.168.8.1 API device signal and press enter. These are the UE-related measurements used for radio resource management. Right-click on this page and select View Page Source to display the details of the outputs such as RSRQ, RSRP, RSSI, and SINR. Record the readings in the table. Repeat this experiment with 50 PRBs and 100 PRBs, eNodeB configuration. Based on the measured results in this table, the best link is achieved for 50 PRBs. The link condition for 100 PRBs is not so good due to the low received signal power. For 25 PRBs, the interference plus noise power is slightly higher compared to that of the 50 PRBs, probably due to higher noise caused by synchronization error and RF front-end distortion. In this experiment, assume the highest MCS index 28, 64 QAM with the least coding, which is mapped to the TBS index of 26. The average measured download data rates for 5, 10, and 20 MHz bandwidths are 13.27, 22.41, and 32.79 megabits per second, while the estimated maximum download data rates are 18.336 megabytes per second, 36.696 megabytes per second, and 75.376 megabytes per second respectively. Similarly for upload, with 64 QAM disabled, we assume the highest MCS index 20, which is mapped to the TBS index of 19. The measured upload data rates for 5, 10, and 20 MHz are 7.81 megabytes per second, 17.41 megabytes per second, and 17.80 megabytes per second, while the maximum upload data rates are 10.680 megabytes per second, 21.384 megabytes per second, and 43.816 megabytes per second respectively. The measured data rates are lower than the estimated maximum data rates. The difference increases when the bandwidth is higher. Possible reasons are changes in the MCS index, as indicated by the results in Table 3. The poor signal quality produced by the SDR, especially for larger bandwidth and higher order modulation. The performance limitation of the PC, which is serving as both eNodeB and EPC. The condition of the network, that is, the campus network and internet, during the measurement.